Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week. This week, James is taking on this question sent in by listener Kate.
How long does the water cycle take to complete a circuit from meltwater to evaporation to snow and ice and back again? Over what size landmass and area does the water cycle take place? Thanks, Kate. All of the water on Earth, from what comes out of your tap to the water vapour in the air to sprawling polar glaciers made of ice, is the same water that's been here for billions of years. The water cycle is the continuous flow of individual molecules around the whole Earth atmosphere system. But we can also think of it on a more localised scale. Here's Dr. Jess Newman, Associate Professor of Hydrology at the University of Reading.
If we take a little water droplet and it might fall straight into the sea, for example, it's come out of the clouds and precipitation straight into the sea, the sun comes out, heats the surface of the sea, and we get evaporation of that water back up into the atmosphere. It could reasonably, within a few hours, fall back down as rainfall again. That's not impossible. So we could be thinking of it in terms of quite a localized area in terms of distance, but also in terms of time. And then we can have a case where perhaps this water, let's take from the cloud again, falling as rainfall. And let's say it falls onto the surface of a leaf. It might then make its way, drip off the leaf onto the ground. It will then infiltrate into the soil. It can then make its way very slowly through the soil and the rock, and may then go into something like a store, like an aquifer or groundwater. And potentially it could take years to reach that store. And it could then stay in that store for hundreds, if not thousands of years until it's abstracted back out or makes its way through what we call base flow, so it will flow through the rocks back into our rivers. So it can happen pretty quickly, and it can happen over a really, really long time scale, depending on where that little molecule decides to go and which pathway it takes.
So the water cycle operates on many different scales, giving us many different time frames for the journey of an individual water droplet. But let's zoom in on the particular section of the huge circular machine, so beautifully described by Jess, that we're interested in for your question, Kate. Meltwater, liquid H2O released from warming snow and ice, usually from a glacier found predominantly in the polar regions.
So if we were to assume that water gets released from its frozen state, and it might have been in this frozen state in, say, a glacier or an ice sheet for thousands of years or hundreds of years, it might go straight into the sea. It can then stay in the sea as a store or an ocean for a very long time, or it might evaporate and go up into the atmosphere. And generally the accepted, although disputed, decision about how long water stays in the atmosphere is 8 to 10 days, but that's going to be different over different parts of the planet, depending on conditions and environments. But let's say that ice sheet is on land, or the glacier is on land. So that water droplet, again, it might go straight into the ground. So it becomes a liquid form, and it infiltrates through the soil and into the rock. There's going to be loads of different pathways, almost infinite directions that this water molecule might take. And it's going to be very much dependent on what's happening in the landscape at that particular point in time as to where it's going to head to.
It's fair to say, Kate, that you've drilled into some of the droplets with potentially the longest water cycles on Earth, caught in several choke points, like being locked in an ice sheet or as a liquid in an aquifer deep underground. The thousands of years this might take to complete such a cycle dwarfs the several hours some droplets may take to fall as rain, say, into a tropical body of water before taking off back into the atmosphere. Something which, for me at least, is fascinating to think about. Thanks for your question, and to Dr. Jess Newman, Associate Professor of Hydrology at the University of Reading, for the answer. Next time, we're answering this question from Simon. Is green technology causing climate change? It seems to me that we've turned the planet off for a few years during the pandemic, and rather than problems being better, they've got dramatically worse.
Question of the Week is part of the Naked Scientists podcast and supported by the Wellcome Trust and UK Fast. Look us up online at nakedscientists.com.